So I'm going to take you through the Mathematics for Engineering paper from January 2017. Just going to outline it for you very briefly, and then you can go away and attempt the questions in your own time. The time allowed here is 1 hour 30 minutes, but the main thing here is just to get back into the topics here. So don't worry about the time so much, just try and understand the topics that have been asked and try and solve the questions. Some general comments from OCR here, so I'm in front of all the exam papers. All your answers should be supported by working, so make sure you put your solutions down. It says that marks may be given even if the answer is wrong, so again make sure all the working's down, nice clear and coherent way, so you get marks even if the final answer is wrong. But an answer that is correct without working may not be given any marks, so be aware of that. You need to show enough of the process involved to show you understood the correct method to get marks given for the question. Just because the answer is correct with minimal working, you'll probably get no marks for that particular question. And this paper is out of 60 marks, it says. Question 1 part A. This is a simple equation to solve. 2x plus 3 is equal to 7. We need to rearrange the equation to get the x terms on one side and all the constants on the other, and that will give us our solution. So simple equation, one unknown, the unknown is x. There's 2 marks associated with that question. Question 1b part 1, we're asked to multiply out and then simplify the brackets here, the x plus 2 multiplied by the x minus 3. This is a binomial bracket expansion and simplification problem. So as we did in the lesson, we expand the brackets. I use the crab claw method, expanding in this form. You don't have to use this method if you don't want to, whatever method you prefer. And expand the brackets out and collect the like terms together. So that's expansion and simplification. And there's 2 marks for that. Question 1b part 2, we're asked to factorise the equation x squared plus 2x minus 15. So this is a factorisation problem, and this is the quadratic equation. So what we'll end up with is 2 brackets here, side by side, multiplying the brackets, and we'll have x and x in the beginning of the brackets. Then we decide what the other terms are, and I'll let you decide that. So that's factorisation of quadratic equation, and that gives us 2 marks here. Question 1c is actually factor theorem. What we're given here is a function of x is equal to x cubed minus 3x squared plus 4x minus 1. Now the first part of this question is to find the value of the expression there on the right hand side if x is equal to 1. So all I want you to do for the first part of the question is to put the value of 1. Wherever you see an x on the right hand side of the equation, you just put the value of 1 in and you evaluate it. What answer do you get when the x value is 1? There's 1 mark for that. In part 2, they want you to explain whether the result from part 1 shows that x is equal to 1 is a root of the equation function of x is equal to 0. So a little bit of explanation there. Depending on the value you've calculated in part 1, you need to say whether it is a root or not and why it is a root of the equation if so. There's 2 marks for that explanation. That's probably descriptive explanation there. Now question 2a here is actually a graphical question. It's sketching graphs basically. So what they've given us is a graph and the plot there below of y is some function of x. Okay, so y is equal to a function of x. They've given us this looking like cubic type curve here really. All they want us to do with this question is to sketch the transformations that occur in part 1 here when we have y is equal to a function of x plus 2, and in part 2 y is equal to a function of x plus 2 in brackets. So what we need to do here is think of the effects of, first of all, in part 1 adding 2 to the function we're given, and in part 2 having 2 inside the function we're given. Now to help you think about this, if we let just think of a more simpler function, let's let the function of x in this particular case, let's let it equal to x squared. Okay, so the first question they're asking us to do, first part of the question here is saying, okay, let's have y is equal to x squared plus 2. So supposing we plotted the x squared curve, which is a bucket shape, we plot the function of x is equal to x squared on a graph, it will simply look something like this, a kind of bucket shape for a quadratic. So the first part of the question is saying, okay, what's the effect of adding 2 to that curve? What would it do? Would it shift it up, shift it down, shift it left, shift it right? That's what it's trying to get us to decide. They've given this more complicated function, but again, all they want to know is that function going to be shifted up, shifted down, shifted left, shifted right? They just want the sketch of that. So if you think it in terms of x squared and what happens to the x squared curve when you add the 2 to it, the same thing would happen to the graph shown on the sketch. Likewise with part 2 of this question, they're now saying, okay, suppose we have y is equal to x plus 2 all squared. So the 2 is now inside the function. What would be the effect on the graph of plotting that? Okay, so again, if you think of it in terms of x plus 2 squared, what does the effect of having that 2 inside the function do to the graph? You could just take a few points and plot that. And the effect of that again will be the same on this graph. So if having the plus 2 inside the function shifts it up, down, left or right, then that will be the same effect on the more complicated curve they're showing there. They just want you to sketch the generic transforms that occur. There's 2 marks for each of those sketches. In part B, they've given us another function, y is equal to gx. Again, that's just a function, and that's sketched for us below. This time we've got to sketch on the graph the effect of having y is equal to 2 multiplied by the function gx. So in this particular case, going back to what we did on the previous slide, let's let our function gx equal to, let's give it x squared again, it looks a bit like an x squared curve anyway here, kind of shape. So what's the effect they're saying for having y is equal to 2 multiplied by the x squared? So if you think of the function as equal to x squared, what's the effect of having 2 in front of it? So is it going to shift the curve to the right? Is it going to shift the curve to the left? Is it going to invert the curve? Is it going to make the curve steeper? Is it going to make the curve more shallow? All these kind of things we need to consider. So again, I'll leave that with you to think through, because whatever the effect is on the x squared curve, that will be the effect on this curve here. And again, just want you to sketch on the graph what that effect is. So part C here, we're given the graph of the equation shown below. The equation is 2x plus 3y equals 24, and that's drawn on the graph. What we've got to do now is plot a linear line of the form y is equal to 2x. So we've done this kind of graph plotting before. Given an equation, we have to plot the line. So what you need to do is to plot on this graph what that would look like. Well, obviously when x is equal to 0, y is equal to 0, so it's going to go through this point. But it's going to have some kind of steepness, which I'll let you decide. So you'll have some kind of line, something like that, that you will draw on the graph there. So 2 marks there for plotting the line y is equal to 2x. You need to plot it quite accurately in this particular case. Part B wants us to find the solution of simultaneous equations. The 2x plus 3y is equal to 20. That's the one that's drawn on the original graph there. And then we've just drawn y is equal to 2x. So there's 2 ways of solving this. The first way, and probably the simplest way, is to read the graph itself. So for example, if I was to read off the graph where the 2 graphs intersect, if I was to read off here, this would be the value of x, and this would be the value of y. Depends on how I draw my graph, of course, as to what those values are. Alternatively, you could solve this using simultaneous equations. We just need to make sure they're in the right format here. So we would have 2x plus 3y is equal to 24, and this equation would have to be rearranged slightly to get all the x and y's on the same side. So we would subtract 2x from both sides, so we'd have negative 2x plus the 1y is equal to 0. Those would be our 2 simultaneous equations, and if we were to literally add the equations together, we would be able to solve for y and then back substitute for x. So slightly more lengthy solution using the simultaneous equation approach, but you could find the x and the y through that method. There's only 1 mark here, so it more likely wants you to read off the graph, but you need to make sure you plot the y is equal to 2x correctly to get the correct solutions for x and y. The simultaneous equation approach doesn't relate to the graph, so if you got your graph wrong in part 1, you could still get it right in part 2 using this method. I'll let you decide how you want to solve that, but basically that's solving simultaneous equations either using a graphical method or using an analytical method. Question 3 here. This is a simultaneous equation question. We've covered many questions like this in the lessons. What you've got here is a scenario. And if you read the question carefully, you'll be able to generate two equations. They've put this in terms of x for the cost of a spanner and y for the cost of a screwdriver. So x and y they're using. They've actually broken the question down for us quite nicely. In part 1, they want us to generate the two simultaneous equations in terms of x and y from the information given. So that's generating the equations, 2 marks there. And then in part 2 here, they want us to solve the equations to find the actual cost of a screwdriver and a spanner. And there are 5 marks for the solution here, so 7 marks in total here. So very useful marks to obtain here. Very similar questions to what we solved in the lesson. There's also a video on simultaneous equations if you want to look at that, which solves very similar kind of questions. I'm going to leave that with you to attempt that question and try and solve it. I would suggest here the elimination method of solution is probably the easiest method to use. This is part B of question 3. This is actually an evaluation problem. In other words, just really putting numbers into an equation given. We're given in the question the equation of v squared equals u squared plus 2as, which is a linear motion equation you've come across in science, and you're given the various values. When they say speed here, they mean find v. What's the value of v? So you're going to have to use this equation, put the values into it, and find v, not v squared. 3 marks associated with this question, so again I would say a reasonably straightforward 3 marks to obtain there. Just read the question carefully, extract the information carefully, and show your working. Put the numbers into the equation or rearrange the equation to find v. Question 4 here, this is to do with statistics. We're given a life of a sample of batteries, that's the context given here, and we're given a table of information. On the left hand side we've got the categories. It's the life of the batteries, so number of batteries that lasted less than 100 hours. There was no batteries in the frequency column that lasted less than 100 hours. Number of batteries lasted between 100 hours and less than or equal to 120 hours. That was 14 batteries. Number of batteries lasted between 120 hours and less than or equal to 140 hours, or 26, and so it goes on. What we've got to do is fill in the cumulative frequency column, this column here. So you need to understand what a cumulative frequency is, and we've got to fill in a table, fill in the missing entries here. Alright, so basically fill in the cumulative frequency column here. I'm going to let you go away and think about what the cumulative frequency is, and then complete the table for 2 marks. Question 4 part 2 wants us to complete the cumulative frequency graph shown below. So it's a continuation of the previous question, all that cumulative frequency curve here. We've got to plot the points from the previous table related to the cumulative frequency curve, and we've got to join up the 2 segments of the curve shown here to form the complete cumulative frequency curve. And cumulative frequency curves are always of an S kind of shape, which is what we've got here. So try and be as accurate as you can when you plot the points during the curve. Question 4 part 3. This is basically reading the information off the previous cumulative frequency curve. So we're still related to the statistics question, and we're just using the cumulative frequency curve. So in part A here, we're asked to find the median value reading from the curve. Part B, we're asked to find the interquartile range, again reading the information from the curve. And then part C, we're asked to find the percentage of the batteries that last less than 175 hours. And again, we need to extract the information from the curve. So there are 6 marks here, all to do with reading the information from the cumulative frequency curve on the previous slide. So again, I'm going to let you engage with this. You need to go back and find out what the median value is, what the interquartile range is, and how to find the percentage of batteries that last less than the 175 hours in this case. So 6 marks here for reading information from the graph. Question 5 part A relates to the integration process. So that means integrate the cos 3x with respect to x there. All they're really asking us to do here is go to the formula sheet that's given to us, look at the integral table we're given, find the functions for cos ax, and then integrate it appropriately. 2 marks for just simply writing down that solution. Part B relates to using differentiation. We're given an equation for height in this case. H is equal to 20 multiplied by t minus 5t squared. So if you like, the h is the y on the left hand side and the t is the x on the right hand side. And by differentiation we've got to find the equation dh by dt. So we've got to differentiate, again using standard forms. In our formula sheet we'll find a differential table. So basically each of these are a standard form. This is ax to the n, this is ax to the n. They're both in standard forms here, and we can differentiate them using our standard tables. In part 2 we're asked to find the time when the ball reaches the maximum height. So when it's at maximum height, don't forget it will have 0 velocity, and we basically found the velocity, be careful here, we found the velocity from the previous part of the question. So by using that equation and rearranging it, we'll be able to find the time at which the maximum height occurs. Basically you're looking at a turning point here. But basically it's using the equation that we've derived in part 1 to rearrange in part 2 for t. And there are 2 marks for each of those parts of the question. Question 5, part 3, a continuation of the previous question. We've now got to find the maximum height of the ball. So find the height h in this case. That requires us to substitute the value of t we got from part 2 into the equation for h that we're given. 2 marks for finding the maximum height. Now part 5, question C, we're given an actual exponential equation here, and if you look at the equation given, it's very similar to the kind of the questions we've looked at in the lessons. Again, there was a video on these kind of problems if you want to review that. And we're going to have to rearrange the equation to find the little t. It's little t you're after in this particular question. So you'll have all the information you need from the question to solve it. You're given the capacitor, which is the value of C. You're given the resistor here, the value of R. You're given the 12 volts of supply, which will be the Vs in this case. And you're given a potential difference, Vc, which is on the left hand side of the equation. Vc is given in the question. So you're given all the information in the question you need except for the value of little t. So you're going to have to rearrange the equation and then take natural logs of both sides of the equation. So I'm going to let you play with this, see what you can do, but basically it's an exponential equation that you solve by rearranging. And there are 4 marks associated with this problem that's worth having. Question 6a, this relates to a trigonometric problem. We're given a triangular lamina, it's a 2-dimensional shape. We're given the corners, if you like, of the lamina, the A, B, C, the angles here. 3 angles are given to us in the question, and we're given 1 side length. We're asked to find the side length AB. So the first thing I would do here is extract the information from the question, sketch a diagram of the triangle as best you can, make it nice and proportional, label the triangle, the corners are labelled A, B and C with the angles, and you've got to find side length AB given side length BC. Okay, so BC is given in the question, so sketch the triangle, make it nice and clear that you know where BC is. It's 10 centimeters long, and then you need to find the lengths of AB. So make sure your sketch is proportional, make sure your sketch is nice and clear here, because it depends on the sketch as to whether you get the right side to find. 3 marks associated with using the appropriate method there. I'll let you think about that. In question 6 part B here, we're given a triangular cross section. It's a prism, and we've got 3 sides of the triangle given. So again, I would sort of sketch the triangle here. We've got to find the largest angle for the cross section. So again, this is a trig problem, and we've got to find the angle opposite the longest side in this particular case. Quite a few marks here. So within this question, you need to decide whether you're using the basic SOHCAHTOA, the sine, cos and tan function, or whether you're using the sine rule, the cosine rule, or the sine rule and the cosine rule. I'm going to let you think about the solutions here, but that's the kind of topic area that we're dealing with. And there are 7 marks associated with this particular part of question 6. And finally, question 6 part C, we're given the sector of a circle having an arc length of 5 centimeters. We're given the radius of the circle is 10 centimeters. We've got to find the angle of the sector in degrees. To me, this is jumping out as being a radian measure problem. It's a geometrical problem, and I would suggest we use radian measure. If you remember, the S is equal to R theta formula, it's in the formula sheet. You could rearrange that to find angle theta, but don't forget, very important in this question, you must state the final answer in terms of degrees. And if you use the radian measure, of course, the answer will be in radians. So there'll be a conversion there. So radial measure is not the only way to solve this problem, but I think it might be a useful approach to solving this problem. There are 3 marks associated with this question. And that's the end of the question paper. I would strongly encourage you to engage with the paper and have an attempt at it. Any problems, get back to me and I'll try and help you with the solutions. But I do want you to engage, first of all, with trying to solve the problems. I would not worry too much about time constraints here. Use this paper to engage back with the material. So if you're taking longer than an hour and a half to solve, don't worry about that for the moment. Just try and engage with the various topic areas. In later papers, we can then think about trying to work to the time constraints. But for the moment, get familiar with the topic areas, understand the way the question is presented, what they're asking you to do, and just make sure you can solve the questions.